Ma'am?
Hello, everyone. Good morning or good evening. How are you people? Okay. So now the point is we'll be focusing on the next topic in the list that is about the Kubernetes deployments. Okay. Um, okay. Hope you all can hear me.
Yeah, yes.
All right. So in today's session, we'll see how to deploy your pods using this deployment controller object. For example, when we talk about the pod, right, it is just to run your application containers and able to take care of your high availability and other stuff, right? To the smallest unit of task that you will deploy. But in our SD session, we just deployed only one instance of pod, just create only one copy of pod, and it was deployed in one particular node, that is work node 1. So here the challenge is like, if you have one copy of pod deployed to one server, there are a lot of chances that the pod might get into crash state, or that worker node which is responsible to run the pod might not be available, right? So if the node is down, automatically the pod, whatever gets deployed into the node will not be available actually. So it will impact your application's availability. All right. And also, if you have only one copy of pod, right, and if you try to upgrade that, definitely you have to create a new version of it, which will lead to some downtime. Okay. So without any downtime, how you can able to achieve your upgrade? For that, we have to rely on the deployment controller object. Correct? So deployment controller object is one of the Kubernetes controller objects, which is used to ensure high availability of your pods. It actually creates the replicas and manages the replication. So here we have two things. One is the replica set, and then deployment object controller. So what does replica set means? It is used to create the replicas of your pods. So using replica set, we can able to create or execute the specific number of pods in a cluster. So this is the basic. So let's say I have an application image, and based upon that image, I want to create some copies of pods, some number of pods, and I want to deploy in a cluster means for that we'll be using replica set. And this replica set is based upon the set based operator. It means you can able to assign any number of labels or environments to deploy this. And another important thing is using replica set, we can able to quickly scale up or scale down the pod instances. And also it can be automatically created while creating your deployment controller object. So you don't need to manually create the replica set. When you create a deployment controller object, this replica set will automatically gets created. So what is the purpose of this means? Consider I want to deploy one application service. Okay. And to deploy this service, please, to deploy the service, is I'm audible or like an issue?
So far, you're audible, but your voice gets cut in between. Gets cut in between.
1 second, let me check. I think now it should be fine, right?
Yeah, it is so far. We'll let you know. No problem. Please proceed.
So consider I have an application service, and to deploy this application service, let's say I have 100 replicas of pods. Okay. Because I expect more number of users will be trying to access my pod or application service. So at least I need 100 copies of pods to support my application. If I have only one copy of pod, and if thousands of users trying to access that one instance of pod, it might not be reachable. So to distribute the workload and ensure high availability of the pod, I'll be creating some replicas of pods. But over the period of time, if the number of users are getting increased, let's say from 1,000 users, if it is getting increased to 10,000 users means I should able to quickly scale this up, right? So how we can able to scale up the replicas of pod means by using the replica set. So using replica set, we can able to scale up or as well as scale down the pod instances. This is one thing. And the second thing is, in real-time environment, you no need to manually create replica sets. When you create a deployment object, automatically creates a deployment object. So deployment of control object is something next level or advanced level of your replica set, which is going to utilize the underlying properties of replica set as well as it is having its own advanced features. So using replica set, if you can able to create replicas of pod means same thing is applicable here also. But here, this deployment control object, it is promptly used to ensure high availability of your pods by creating some replicas. So here we can able to create multiple instance or replicas of pods, and we can able to quickly scale up or scale down the pods. We can able to upgrade the application pods as well as we can able to downgrade or roll back. So all these upgrade and downgrade can be done without any downtime. That is another important capability, but you cannot achieve this with replica set. With replica set, you can simply create the pod instances, that's all. If you want, you can able to scale up or scale down, but you cannot ensure that zero downtime there. So to achieve zero downtime and keep your pods in its own desired state, we use deployment control object. So how this deployment control object can able to achieve zero downtime means it uses the deployment strategy called rolling update deployment strategy. Correct. So rolling update deployment strategy is a default strategy for deployment control object. So what it means here, I'll give you one scenario. Listen, please. In our previous session, I was talking about your oh, it's for you people or like, okay, no problem. Listen, please. So consider I have an application image. Okay, I have this program, and with this, I can able to create the artifacts, right?
Yes, correct.
So the same level, like what are the components we have, what are the versions we have, I can able to build that application and create the artifacts out of it. So once we create the artifacts, the same artifacts can be used to create an image. So assume that with this same Java program, I can able to create one image. That is also version 1.0. But before I create this image, I'll be using this WAR file. 1.0, right? So I got these three output components. So once this image is ready, I'll be publishing this image to my container registry. Once it is published container registry, I can use my Kubernetes to deploy this image into the target environment. But then our point here is this image is going to get executed as a pod. At least I'll be having pre-instance of pod, like pod 1, pod 3. So 3 copies of pods will be deployed. And all these 3 copies of pod will be having the same version number, correct? Agree. When I talk about the replicas of pods, if I say replica count as 3, it means I want 3 copies of pod. And all these 3 copies of pod will be having the same image. Even if one pod is down, I can have another pod to support my application. And these 3 copies of pod can be distributed in more than one worker node. Like this can be running in worker node 1. And this can be in worker node 2, and this can be in worker node 1. So out of 3 copies of pods, 2 copies are running in worker node 1 and this is running in worker node 2. Like this, your scheduler will distribute your workload. So even if one worker node is down, I have another worker node to support my application with pod 2. So this is what we call it as high availability. So we can able to deploy the pods and ensure high availability of pod by creating replicas. This is fine. This is a basic property. But now assume that developer has created a new version of the source code 2.0. Based upon that, he has created the war file and deployed another version. Already the pod is running with v1.0 and now we have to upgrade this. So upgrading means it is not just upgrading your pod, you have to upgrade all the pod instances. Correct. If you are following the traditional deployment process, what happens, it will just replace the existing pod. While it is replacing, definitely it will delete the existing version and create a new version. That's what replacing, right? The existing version is running with 1.0. So first it will remove that version and create a new version. If you try to do the traditional way of deployment or upgrade, all these 3 instances of pods will be down and immediately will create a new version of the pod. During the time, there will be some downtime. So how we can able to avoid this downtime means by using this rolling update strategy. So using rolling update strategy, how deployment happens means, listen here, the latest version v1.0, right? So this version will be applied to a pod 1. It'll take the very first instance of pod and apply the new version of the image. While it is applying the new version of this image to pod 1, the remaining 2 instances will be running with the previous version. Easy? If you do it all together, you will experience the downtime. But if you're doing it one by one, there won't be any downtime. So that is a rolling update strategy. First, it will roll out the very first instance. If the deployment is successful for pod 1, then only it will update the new version to pod 2 and 3. Got it? So while we are updating pod 1, this pod 2 and pod 3 will be up and running. It means the application is still live. End users can keep on running that application, using the application. Once this pod 1 is successfully completed, then it will delete this pod 1, older one, and it will try to update the pod 2 instance. And similarly, it will try to update the next version. So this is how the upgrade will happen by default in Kubernetes. Similarly, if you want to downgrade, the same strategy. Let's say this 2.0, it is not working as expected. You want to undo the changes means with the same rolling update strategy, it just take the changes back to your previous version and removes it. Easy? Are you able to understand the process behind your deployments, how the deployment happens in Kubernetes, or any question?
So, Loksai, in the previous one, before the rolling update deployment strategy, what was the other one? The replica set.
Replica set, it is a property, one of the properties of your deployment control object.
Okay, so in that, all the pods will get updated automatically all together.
Here we never consider for deployment actually or upgrade. It is just to create the replicas.
Okay.
Correct. It is just to create replicas. Here there is no deployment strategy. If you want, you create a new pod instances altogether. Altogether, if you have 5 instances, means all 5 instances will be created again. But if it is a deployment object, it uses replica set to create the replicas, as well as it is having unique features called rolling update strategy to update the images one by one.
Okay, depending upon the images available in the Docker registry.
Yeah.
Okay.
Easy. So I'll show you how to work on this now. Let's get into the console. So we have just two more topics. We are talking about deployment, scaling up and scaling down application, and also we talked about the services. We'll talk about the volumes and namespaces. Once we complete this, I'll show you how you can able to implement with Jenkins. Or I strongly recommend before we talk about Jenkins implementation, you need to practice once.
With practice, you mean we need to practice Jenkins or Kubernetes?
I'm talking about Kubernetes only.
Okay. And one more thing, meanwhile you are doing this, Loksai, may I ask something?
Yeah,
Okay, so yesterday you told us that application pod runs in their own namespace, right? Default namespace, sorry.
yeah,
And yesterday we created a pod that was for the Nginx service.
yeah.
So that was the reason that namespace was written there, because that was not an application.
It is not like that actually. So it is running in a default namespace, right? It is running in the default namespace. Let me show you this again. We just started the instance, right?
Sure.
Mm. What next? So we are in master node. And if I say kubectl get nodes, we have all these three nodes up and running, ready for deployments. And if I say kubectl get pods, you can see one pod is available and it's up and running. And if I say kubectl get pods -o wide, you should be able to see this is a pod which is running with this IP address in worker node 1. So whenever you create any pod, by default, the pod gets deployed in the default namespace. Say for an example, if I say kubectl get pods, all namespaces, you can see this nginx -pod, which we have created yesterday, it is running in default namespace. One copy of pod is up and running. You see?
Yeah. Namespace default, correct.
Similarly, we have created a service, kubectl get service, SVC. You can see that nginx-pod name service is running in default namespace, which we have created yesterday, right? So like this, what are all these services or objects we create, it will be allocated in the default namespace. If you want, you can create your own namespace and deploy it. We have a separate topic about namespace. I'll talk about it there.
Done.
Now, let me go to the folder and we are going to create one manifest file to implement this deployment controller object. So what are all things we can able to create with the deployment controller object means this deployment controller object can create three entities. One is your deployment object itself. When you try to create a deployment object, it creates a deployment object and then it creates a replica set, and then based upon the number of replicas, it creates the pod instances. So to work on this, I have a separate manifest file. So if you can see this example here, listen carefully. So this is a manifest file we are going to create for this deployment object. Listen carefully. As we discussed already, the manifest file should be saved as YAML file, or if you want, you can able to use JSON format as per your company standard. So we are going to create an object type called deployment. Yesterday, we have created the pod. Hope you remember this. And now we are going to create a deployment. Okay. And the API version for deployment is apps/v1. Metadata that is used to identify the name of the deployment object. As like how you assign the name to your pod, you're going to assign a name to deployment object. Now, you are going to assign a label to this deployment object. It is just traditional tag we are assigning to it. Okay. And we have a specification. What is the purpose of specification here? Usually the specifications are used to define the container specification. Like what is the name of the container? What is that image, container image, and the port number? This is what we define in this specification, right? But if you talk about any deployment controller object, under specification, first we have to give a replicas. How many replicas of pods you want to create? That replica count has to be defined first. And then you'll be defining the properties of the pod within a template. So in our yesterday session, we were trying to create a pod. Within the metadata, we have given the name of the pod, labels, and then the specification. So all this content related to a pod should be coded as a template here. Can you see this? Starting from metadata, specification, everything is coded under the template. That's the difference. So this is a simple pod definition, but here the pod definition is considered a template. Why it is considered a template means using this template only, your replica set is going to create 3 replicas of pods. Easy. And while creating your pods using the deployment controller object or replica set, you no need to assign the name to your pod. Like you can see here, yesterday we were using a metadata, in that we have a name. Because it is just one copy of pod, we are manually given the name of the pod as nginx-pod. But when you try to create the same pod instances using the deployment object, the name is optional, because the pod is going to get executed or created using this deployment control object name. It just creates a name automatically. Randomly it assigns some name to a pod. Correct? But apart from that, the label is mandatory. Label is very much important. Through this label only, your deployment control object can able to identify the template. And then the specification within the template is used to identify the container specification. You see, I repeat, to create a deployment control object, the kind should be deployment. API version should be app/v1. Metadata, it is at the deployment level used to identify the name of deployment as well as the label. And then the spec with the replica count and the template that is used to define the pods properties. Label is mandatory there. So how the flow of execution is like, this template is within the specification and number of pod instances based upon replicas. So how the deployment object can able to identify the template means by using the label of the template. So here the label is app nginx app. So to refer this label, deployment object uses a selector key. So we have a selector key. With this selector key, we are going to map the match labels. So the templates label is app slash or app colon Nginx app. So this we have to assign. This we have to assign as a label to your template, and that will be referred in your selector. So when you try to execute this manifest file, first it will create a deployment object. And based upon the deployment object, it creates a replica set. That's what I told you. There are 3 outputs here. And then deployment replica set. Once replica set is defined, based upon the number of instances, it should create the pod instance, right? So to create a pod instance, it has to refer the label of that particular template. So it look into the selector key and get the label and search for the template that is matching this label and uses the container specification from there. Simple. Let's create one. And in this example, if you noticed, I'm going to use an image called Nginx stable hotel image. It is a version. Yesterday, I was just using the latest version, but today let's use some previous versions. Stable hotel version is one of the versions. If you go through your container registry and search for this version, you can find it. Got it? And the port number, as usual, it's 80. Now let's create one.
Looks like I have a doubt. So what if it doesn't mention that the label name?
It will not work. It cannot create a pod. To create a pod, it needs a pod reference that is done by your template.
So instead of name, we for replicas we use labels. For mentioning that.
Yes. Even if you assign the name of the pod also, it won't consider that name. I'll show you how it works. Okay, like once we execute, I'll show you this. So any other question on this manifest file? Like
in version, we are using apps/v1 and creating a simple pod, we were using v1. So this all these details you will get in that URL.
official documentation.
Yes.
Yes.
Okay.
There you can find the details. Okay. Now let's save this. And to create the pod or any Kubernetes object, we use the same command like kubectl create command -f followed by the file name. It's created now. And if I say kubectl get pods, get deploy, you can see nginx-deploy is what we have created. Name of the object, deployment object. We have created with 3 replicas. So it is ready with 3, up to date and available as 3. It means 3 copies of pods are created using this nginx deploy. So the first entity is ready now. And the second component is replica set. So if I say kubectl get rs means replica set. See, the replica set name also, it is created based upon the deployment object name. It has assigned one random value, unique value to that replica set with 3 replicas. And all the 3 replicas of pods created using this are ready now. So now if you say kubectl get pods, you can see nginx deploy. Based upon this name, it has created 3 replicas of pods. Don't consider this one. This was created yesterday. Okay, it is not part of this execution. The latest 3 things, right? 3 copies of pods are up and running now. Easy. So if you see the name of the pod, it is actually driven from the replica set. It uses the replica set name as a prefix and assign the last 5 characters to uniquely identify the pod name. Easy. That's the reason I told you the pod name is not required while creating your deployment control object replica sets. Easy. Now, another important thing is you can able to use your kubectl describe command to describe the properties. See here, we have created one new deployment object. It is running in default namespace. On this date and time we created it. This is a label we assigned, app equal to nginx deploy. This is a label we are assigned to this, right? You can see this is a label. Here, nginx deploy LBL. And it is using the rolling update strategy. You can see with the 3 replicas of pod. The selector key uses the app equal to nginx, and it is having 3 replicas of pods. All are available. Nothing is unavailable. And also you can see each and every copy of pod is using this nginx stable hotel image, because that is what we are defining in our file. So based upon this image version, it is up and running, and you can able to see the port number also assigned to this. Correct. So in order to quickly test this, right, we usually use some grep command and filter that. Like, consider I use this grep command. See here, from this output of describe command, I just want to search only for the keyword called image. So using grep command, I just filtered it out, and I can able to see this deployment control object is running with stable hotel version. Similarly, if I get the list of pods, okay, if I say kubectl describe pod followed by the pod name, any pod name you can give. See, this is the pod which is up and running, name of the pod running in default. And if you can see the image, it is using stable hotel. So all the 3 copies of pods will be running with the same version of your image. Hope it's clear now. 3 copies of pods are running with the same version of your image. Any question? So with this, we have created some replicas of pods automatically. No need to create it manually. And another interesting factor here is, if I say -o wide, see, these 3 copies of pods are up and running, and it is asking with unique IP address. Each pod has its own IP address, and it is distributed in all the available nodes. So first instance of pod is running in worker node 1, and remaining 2 is running in worker node 2. Scheduler has automatically scheduled the pod deployment. You see? So even if one node is down, your application will be still up and running with worker node 2. And as for the best practice in real-time environment, you should have at least 3 worker nodes. Easy. Hope you all clear with this, or you guys have any question?
And these 3 pods which you just deployed are running under the again default namespace.
Yeah, of course. Everything is under default namespace.
And we can check that using hyphen all hyphen namespaces.
Yeah.
Okay.
Easy. Are we good with this?
Yeah.
Fine.
Yes.
Fine. So apart from this, your deployment grid object can also perform the scale up as well as scale down, I told you, and also we can able to perform upgrade or downgrade. So how to do a scale up and scale down means it's very simple. There is a command called kubectl scale command. So currently we have 3 copies of pods up and running. And my requirement is I want to scale it up. Like if I simply say kubectl scale deployment followed by the name of the deployment object, nginx deploy. No need to specify the pod name anywhere because pods are not the permanent entity, but the deployment is permanent entity. So you can simply create 10 instances of pod, assume that. See, it is quickly creating the pod instances. It has created 10 copies of pods and it is distributed in all the available nodes. 5 copies are running in workload 1 and 5 copies are running in workload 2. Like that, it is equally distributing the workload. So how quickly we can able to scale up, that is the main point here. It is not like we have to manually deploy it in the available nodes. The scheduler will take care of it. So whenever there is a huge traffic, we'll be using some monitoring tool in real-time environment. As part of a production monitoring team, they'll be monitoring the infrastructure, they'll be monitoring network traffic. And whenever the traffic goes high, based upon the threshold limit, they can automate this command execution. So this will quickly scale up. Or if the process completes, okay, if you are done with your process, if you want to scale down, you can immediately bring it down. I just made it as 1, and you can see immediately just delete all other instances. Only 1 copy is available. See how quickly it is scaling up and scaling down. If I say 3, it will again settle to 3 here. You see? So this is how we use your deployment control objects, especially in Kubernetes, to scale up or scale down the pod instances. That is about scaling. And apart from that, there's something called upgrade and downgrade. So whenever you want to change the version of image, let's say currently this pods are running in version stable OTL version. I just want to upgrade it to stable Perl version. Consider I want to change the version of the image. Like if you can see here, currently the deployment object is deployed using the version called stable OTL version. Okay. Now I want to upgrade it. Whenever I try to upgrade it at the deployment level, it will be applicable to all the pod instances. So this is another advantage. Consider you have 100 replicas of pods up and running, and you want to change the image version of all the 100 instances. Means no need to upgrade each and every image, each and every pod instance. You can directly update your deployment object. So this is an example. So if I run this command here, kubectl set image followed by the name deploy and the name of the deployment object. Nginx container equal to nginx stable Perl. It means from the stable OTel version, I want to upgrade it to stable Perl version. This is the next version, like version 1.0 to 1.1. So set image is a command. Kubectl set image followed by the object name, to which object you want to create along with the name. So if I run this command, see what's happening. Let's say this image has been updated. This deployment object image has been updated. If I say apply the grep command and check, now this deployment control object's image name, you should be able to see the latest name. See, it is updated with stable Perl. Earlier it was stable OTel, now it is stable Perl. Now the point is, when we try to update the image at the deployment level, it will automatically update the version in all the instance of pods. Now, if I say kubectl get pods command, let's see what is happening there. If I say kubectl get pods command, you can see it is trying to update the image. It is trying to create the new instance of pod. These are 3 instances of pod that is already up and running, right? On top of it, based upon the latest version of your image, it is trying to create a new pod. As I said already, as per the rolling update strategy, first it will try to update the very first version of your pod with the new image version. If it is successful, then only it'll go and update the second instance. That's what is trying to happen here. It is trying to update one instance of pod, but it says image pull back off. So if I use a command to check the status of this, why it is not happening or what is the status of this deployment, there is a command called rollout status command. So kubectl rollout status of the deployment. See, it is keep on waiting for deployment, waiting for deployment to complete. It has updated deployment object based upon it is trying to update all the replicas of pods, but it is unable to perform the task because that first changes it is not successful. Image pull back off error. So what does image pull back off error means? The image, whatever you're trying to use for this upgrade, your container D is trying to fetch that image from the container registry. It is trying to pull the image, but that image is not present in the container registry. So whenever the image is not present in the container registry, obviously you'll be getting image pull back off error. So waiting to deploy, it will be keep on waiting. Okay, so just give Control C to come out of the command. Usually we'll give Control C to exit from any command, right? So let's update this. Now, the point here is we have something called pod instances. And this pod instance that is trying to upgrade the latest version, but is unable to do that. So what we can do, whenever the deployment is failing, what is the course of action we can do here?
Rollback.
Mm-hmm.
We can again go back to the previous image.
Yes. So to do that, Kubernetes uses one command called undo command. Rollout undo. No need to get into that manifest file and change the image and submit it again. It's not required. Simply say kubectl rollout undo, followed by the deployment object name. Once you execute this, it will try to roll out the just previous version. It's completed. Now, if I try to get the image of the described deployment object, see, it went back to the previous version. Initial version was hotel. We just upgraded to stable Perl, which was not successful. So we just undo that action. Okay, undo the action. So what we can do here is we can go and check the pod list. See, your deployment is failed, but still it is having the previous version of pods available up and running. So what you need to understand here is whenever you try to deploy a pod, whether it is upgrade or downgrade, correct, whether it is successful or unsuccessful during your upgrade downgrade, it won't impact your application. There won't be any downtime. Correct? There won't be any downtime during this process. So that is what the expectation here. In few seconds, let me clear the screen. The pod will be taken back to the previous state. See, the pod which was creating the issue, right? It is removed from the list. So now if you use your kubectl and describe command for this particular pod name, you'll be having the previous version. Sorry. See here, it is using stable hotel version. You see, hope you are getting a point, right? So this is how we can able to know ensure high availability of a pod. So now we got the situation. What went wrong? We understood the image name, whatever we mentioned in that particular command, it is not available. The actual image name is stable-perl, not PARL. It is PRL. So I just intentionally use this invalid or incorrect image name just to show you how you can able to undo the changes if anything goes wrong. Now we are going to use the actual image name, and then we'll be monitoring the status of the deployment also. So if I try to execute this command here, I'm going to use a stable Perl, the actual image name, and it is updated. Now if I try to check the rollout status, see, it is waiting for deployment to complete, rollout to finish, one after the other. This is what rolling update strategy means. So kubectl rollout status command is used to get the status of a deployment whenever trying to upgrade it. So it is taking out of 3 instances, it is updating first instance, and then second, and then the last one. Once it is completed, it is deleting the previous version. Now if I say kubectl get or describe pod name, the deployment object has been updated with the Perl. And if I say kubectl get, what is it called? Get pods, you can see the new pods are created here. Got it? The new pods are created here. So if I say kubectl describe pod followed by the pod name, the latest pod name which got created, you can see it is assigned with PRL, the latest. Easy. So this is all about your deployment control object. It's a very, very important question. And in real-time environment, developers will be using this controller object to deploy the pods. We never create a simple pod as like what we did yesterday. It is just for a demo I showed you. But in real-time environment, if you want to create any image, create it using a Docker, publish to container registry, and that image name you have to specify in your manifest file to pick it up. This manifest file definition will be one-time activity. Then after developer, whenever they want to upgrade to the new version, they'll be simply running this command, set image command. Like for example, this is v1.0 version. If they want to upgrade to v1.2, they just set the image, new image. If the image is available there, automatically it updates the deployment object and creates a new replicas of pods and keep your application up and running. Easy. Am I clear with this?
Yeah, Loksai, when we have changed the image name to the other version here, like stable Perl, so will it get changed in the manifest file as well?
No. Your actual etcd will be updated. The
Okay.
latest version, whatever you have, right? It will get updated.
Okay. But manifest file will still have that old version with which it started.
which you have created, no?
Yeah, correct.
Which you have created in that
Hmm.
directory, it will be same. It's just a static file, right? Which you have created here.
Hmm.
This file, whatever you created, you're not going to directly update anything here.
Correct.
Like, can you
And
hear
this,
me? No.
okay.
Yeah.
So actually, like if we upgrade this I mean, image or something, so we have to have our code and Git, everything is there in that image, right? So that will carry forward, right?
Come again.
I mean, see, when we prepare the image, like we prepare the base image and we install some files and back dependencies, right?
Okay.
Mhm. So that will carry forward that application, right?
Yeah, of course.
So you understand my right? What I'm trying to say, like those things.
Yeah, it will update actually.
Yeah, that's because if we install Python and Java, so
Uh,
those will be updated that image, right? I mean,
yeah, definitely. The image can be anything. It is just an application image, right? It can be of any image. That doesn't
okay.
matter.
Yeah.
Kubernetes is something meant for deployment, okay, irrespective of your programming language.
Okay.
It can be an image related to Java program or a .NET or Python node, whatever it is, doesn't matter. The role of Kubernetes is to take that image, create some replicas of pods, and schedule the pod in more than one worker node to ensure high availability.
Okay.
That's it.
In once we do the project, we'll understand.
Yeah.
Okay.
And looks like, as per the scaling up perspective, I'm just asking. I'm not sure if that is really a fact or not. As per the application perspective, I'm asking. Like yesterday on Hotstar is an application on which people I saw 70 crore people were watching India and the New Zealand's match. So during this, the traffic was pretty huge on the application. So they were using the scaling up technique behind the process.
Yeah.
Oh,
They'll be having an auto scaling group
uh,
and the same process.
okay, okay. Just to ensure there is no downtime.
Yeah.
Cool. Mm.
When we are changing this OTL to Perl, so it will update the latest version of Perl, right?
Yes, that's right.
And if I want to update after 2 months or 3 months, the next version, so
Uh,
would
no, it is not the latest version. See, Nginx is the image name, right?
okay,
If you can see here, Nginx is the image name,
yes,
and this is just a version.
right,
We can't say that this is the latest version,
okay,
right? So
yes,
just get into the container registry and identify the name of the image and go to the tags and identify the image name. Which version of image you want to use, you can use it.
okay. Whatever will be available in that Docker, we can do only install that one also, nothing else from outside.
Yeah.
Okay.
Looks like if you wanted to make any changes of that images, you directly mention it or you just mention it in the that manifest file, usually in real-time environment.
Here you can use it. Manifest file also is one of the methods, but this is the quickest way to update the image.
Okay, in real-time environment also you can use this.
Yeah,
This is the method.
Yeah, this is the same method.
Okay, okay, sure, sure.
And this manifest files template always remains the same.
Yeah,
Okay. So we can just copy this template and we can fill in the records.
yeah, that's right. So this is all about your deployment controller object. You should know how to perform the rolling update. And if anything goes wrong, how you can able to undo the changes, able to scale up or scale down the changes. Got it? So the next item in the list is about the Kubernetes volumes. So when we say Kubernetes volumes, right, it is used to maintain the persistent data. when we say persistent volume, let's say for an example, I have an application and that application is getting deployed into my Kubernetes cluster, that service, one of the services. So when you try to run that pod, right, the application that is running inside the pod might need some data from the external system, or it might generate some data that has to be preserved. So at any point of time, the containers or pods are not the permanent entities. Okay, it can get into the delete state or crash anytime, any point of time. We cannot rely on the internal volume of your container. So if you want to maintain any data that is permanently available, means you can use your volume. That is what we did in our Docker also. Remember how we used our volume, Docker volume, to maintain the data, correct? Even after the lifetime of your containers. Similarly, here we are going to maintain some persistent volumes even after the lifetime of your pod. So out of this, we'll be learning about the host path volume. Okay. So what we're going to do here is the host path volume. It is something used to maintain the data even after the lifetime of a pod. So how to create a host path volume? I'll give you one small example for that. Listen, please. So if you can see the scenario here, this is a small manifest file that is used to create your pod, a simple pod definition. Create a pod with the kind as pod and API version is v1 and the metadata, the name of the pod which you want to create. And the specification, what we're going to do here is we are going to use a container. This is the name of the container. This is the image name. So this is what we did in our previous example also. But this pod was not assigned with any volume. What we're going to do here is we are going to attach a volume. That volume name is test_vol. It is just a name you're going to assign. And the type of volume is host path volume. Host path volume means it will create a volume in the host machine where your pod is up and running. Let's say if you deploy this pod and if it is running in worknode 1 means in that worknode 1, it creates one directory. And that directory which is created in worknode 1 will be synced with your pod volume. That is a volume mount, the mount path -test mnt. So this is a directory present within your volume, within your container. So how this volume and this volume is mapped means by using the name. It is something like in our Docker model, we use a mount parameter, right? Source volume and the destination. Remember, in Docker module, we have created a
looks yeah.
Yes.
volume and we just mounted that volume during the container execution or creation. So we use a parameter mount source as your Docker volume and destination is your container volume. Similarly here, the source volume is your host path and it is getting mounted to your container volume, that is test_mnt. Let me quickly show you so that it will be easy for you to understand. It is just a pod creation. In addition to that, we're just adding this volume, that's all. Save the file and let's create it. FNF followed by the file name. So one new pod has been created. And now if I say kubectl get pods, you can see this pod has been created now, right? So all that we can do here is we can log into this pod now. So I'll show you how to log into the pod. What is the command to log into the pod? exec command, right? kubectl exec. Remember yesterday we used it, right?
Yeah.
kubectl exec -it followed by the pod name. nginx host path, right? Followed by the bash mode. Now I am in the root directory of my pod, and if I say ls, I should be able to see there is a directory called test-mnt is created automatically. Correct. And if I go to the directory test, it is empty now. Assume that this pod is generating some data. It is trying to create some artifacts or something it is trying to create. It is available now, right? If I exit from this pod, I just come out of this pod, and now if I say kubectl get pods, it is up and running. Okay, there is no problem, but where it is running, you can see this pod is running in worker node 1. Sorry, worker node 2. This pod is running in worker node 2, right? So you can log into the node and check the structure. This is a 1, worker node 2. Hope you can understand, right? Let me get into this node. So I am at the root directory, and if I say cd / and ls, I should be able to see there is a folder called test.vol. Test.vol. This is nothing but the folder which we have mentioned as a host path. In host machine where the pod gets deployed, on that machine, you should be able to see this directory. That's what we are seeing here. And in the directory, if I say ls, I should be able to see the file which we have created in the pod. Similarly, if you want to send any input to your pod, you can create a file here. Now, if you try to create or log into the pod again, you can able to find the file. So like this, you can able to send the data in and out of your pod through your host path volume. Easy. Any question on this?
Whatever the volume will get generated there in the pods, we can see that in the
Host
worker
machine.
node, host
Yeah.
machine. And it's just the file, and that will be the volume.
Yeah. Directory, not the file. File is actual content, okay, of that volume. The volume is the directory, whatever you're creating here.
Okay.
Right. So this is one of the types of your volume. And apart from the Kubernetes supports various types, okay, like we have, if you want to manage some configuration files, we have something called config map volume. We have a secret volume to maintain. Everything works on the same principle. Only this term varies. Instead of host path, you just define as a secret or config map. And also there's something called persistent volume. Persistent volume and all, it will be at the admin level, the storage administration level. So we have something called persistent volumes and persistent volume claim. Persistent volume and persistent volume claim. So these are the two things we have in place. So what is the need for these kind of volume? Means it's all at the enterprise level. Let's say I want to deploy a pod and that pod needs around 1 terabyte of volume. 1 terabyte of volume. Can you imagine? Can you expect 1 terabyte of volume in your host machine like this?
Not sure if it is available. It must be very costly if it is.
So in real-time environment, we never have such volumes attached to your host machine. We'll be accessing it from the external storage server. It can be your AWS EBS volumes or EFS volumes or Azure disk or Google persistent disk, or even we'll be referring some on-premise servers, our on-prem storage server we can use. Like this, there are a lot of entities available there. So for handling such a huge volume, it is not just done by the Kubernetes administrator. At enterprise level, there'll be a storage administrators, right? Storage administrators. So with their support only, we can able to procure such a huge volume because it's all cost included, right? So in a real-time environment, to manage your production data and volume, will be utilizing such features, right? So on your day-to-day pods deployment, we'll be using your host path volume. And if you want to manage any credentials or secrets, you can able to use a secret volume. So same as like host path, only difference is if the volume type is secret, the data whatever we maintain the volume will be encrypted. You cannot access it outside the pod. Correct. So when it comes to access level, right? We have something called isolated deployment path, right? That is called namespaces. Like in our case itself, we have seen something like what are things we have seen here? kubectl git ns. So these are all the namespaces available actually. So if you want to create your own namespace, you can able to create kubectl create namespace followed by the name. It will create. But before you create, you should know the purpose of it. So these namespaces are considered as the logical partition of the Kubernetes cluster. Namespaces are the logical partitioning of a Kubernetes cluster, okay? So what is the need for logical partitioning means? Let's say for an example, consider I have a cluster, okay? In this cluster, assume that I have some worker nodes. Like I have worker node 1, 2, 3, 4, 5, and 6 in this cluster. Now, if I try to create or deploy any pod, the pod can be deployed in the default namespace, right? And that default namespace, it is applicable at the cluster level, correct? Right? Default namespace is applicable at the cluster level. It is not applicable for a specific node. Agree?
Yes.
That is the reason you are seeing when you deploy any pod in the default cluster or default namespace, it is getting distributed in all the available nodes. So any namespace we create, it is a logical partitioning of your cluster. So this is one partition. Similarly, we have seen one more namespace called Kube system namespace, where all your Kubernetes core components like API server, everything gets deployed. So it will be partitioned like this. Even tomorrow, you can able to create your own namespace. That is also only partitioned like this. Like it can be for your dev namespace, dev environment, and this can be for your QA environment kind of thing. So point here is, in your previous session, we were discussing about the environments, right? So in general, we have non-prod and prod environment, correct? So if you want to deploy your applications using Kubernetes, we'll be having dedicated non-prod Kubernetes cluster. Similarly, we'll be having a dedicated production Kubernetes cluster. And now in this non-prod Kubernetes cluster, how many environments we can have? In non-prod environment, how many environments we can have?
3.
Like we can have dev,
Build, test.
QA, and then UAT kind of thing. So can I create a cluster for each and every environment? Can I
Yes.
create a cluster for each and every environment?
Yeah, yeah.
Yes, we
Yeah.
can.
How can you say? Already I have a cluster. Assume that I have a cluster with 5 worker nodes that is dedicated to my non-prod environment. If I sorry, 10 worker nodes. If I have 10 worker nodes, means I can able to share these 10 worker nodes, right, to all these environments. So we never create a cluster for each and every environment in real time. So what we do here is we just create one dev namespace. And this is another namespace. This is another namespace. Like this, even in production also, we can have prod active namespace where your applications are live. We never deploy your applications directly in the default namespace. Sometimes what happens, some application team might be expecting the dedicated namespace to deploy the application. Okay, like dev team 1 namespace. Similarly, the testing team needs their own dedicated namespace, like test team 1 namespace. So you can able to create any number of namespaces in your cluster. It's all just a logical partitioning. So it can be utilizing all the nodes for its deployment, but it will be having its own isolated path. Easy?
Yes.
So how to create a namespace means it's very simple. Kubectl will create namespace followed by the name. See, one dev namespace created now. If I get the list, I see there is one dev namespace available. Similarly, if I want to create a QA, UAT and QA environment, I can use QA namespace. For UAT, I can have another. Like this, we can create our environments as per the need. And once the environments are ready, once the namespaces are ready, how you can able to deploy this or use this? Okay, how we can able to use this, that matters. For that, if you say kubectl get pods, all these namespace pods, whatever we deploy, it's all running in the default namespace. Right. And these 3 things are running in funnel namespace, and this is running in the kube system. There is nothing running in our QA or dev or UAT. So how to deploy your pod in specific namespace means very simple. Let me take one example for that. Dev pod. Okay. I want to create one namespace. Pod in this namespace. So I'm just creating a new file or copying the thing here. So I just created this manifest file now based upon the existing file. So let me edit that file. Go to insert mode. So usually we give the kind of pod metadata used to identify the name of the pod. I just want to use a namespace. So when I say namespace is dev, the pod will get deployed in the dev namespace. Pod name can be same. There's no problem. Within the namespace, the pod name should be unique. If you want, you can able to deploy the same pod or with the same name in any other namespace also. That's not an issue. So if you can see this example, if you're not using this namespace key, it will get deployed to the default namespace. But if you mention this, it will get deployed to your dev namespace. Save the file and create it. Followed by the, what is it? Nginx. Created. Now, if I say kubectl get pods from all namespaces, you should be able to see in my dev namespace, I have one pod up and running. Am I clear? So it's again a very important equation, how you can able to create environments in Kubernetes cluster by using namespaces. Easy? Am I clear with this or any question?
So similarly, we can change the namespace for any manifest file.
Come again?
We can change the namespace, or we can assign the namespace in the any manifest file, depending upon the requirement.
See, it is not about changing the namespace, okay? It's about creating a namespace and deploying a pod in the namespace,
Yeah, after the creation, right?
right?
Hmm.
Hmm.
So first we need to create it, then we can deploy.
Yeah. Easy. That's it. This is all about your deployment. So if you are clear with this, you can able to use your existing image that we are used in our Docker module. Have you all worked in Docker module or still anything is pending there? Like I was expecting you to create this Docker file, remember? Using this Docker file, right? Where is it here? This one. Have you all done with this example? Able to copy your war file to the container volume?
Yeah,
No, I
yes.
haven't practiced it yet.
Yes, I have done.
Yeah.
So it means your image is present in a container registry, correct?
Yes.
You
Yes.
already pushed that image to container registry, correct? I think this is what we did in our demo also, right? I was referring to the same image, I believe. Hmm?
Yes, I think you showed this image.
Hub.docker.com. No, it's not the one. Let me check. V1.0. No, this is not that image. We never use that image actually. Hmm? So what you can do here is you can get into your node. Like I think we have installed it in our slave node, right? In our slave node only we have that artifacts, correct?
Yes.
Starting this now. Hmm. And we have something called DevOps admin user, I believe. So su2 DevOps admin user, and here we have the workspace folder. In that workspace folder, you should be able to see something related to your PL directory. Where is it? Okay, I'll do one thing. Let me go to your server. Hey, you want to have a quick break or what? I'm going without any flow break actually. If you want, let me know. Otherwise, it's okay for me. Okay, then go ahead, please. 5 minutes sufficient, no? Yeah.
Okay.
Chala. Hmm.
So I have a doubt.
Yep.
So you have mentioned that the namespace is a logical entity in a cluster. If you have any number of worker nodes. So let's say we can find out in which worker node the actually the namespace, which namespaces are present. If we can able to find out that.
It is not meant for any worker node, right? Any specific worker node, right? It is a partitioning, logical partitioning of a cluster.
Okay.
Right? I never said it is an entity here. It is a logical partitioning of your cluster, basically. Correct?
Logical partition of a cluster. Okay.
Cluster. So it is applicable at the cluster level, not at the edge node level.
Okay.
I am having one issue. Yesterday, while I was using kubectl describe pod and Nginx command, uh, everything was successful. One event was failed. It was showing failed event.
Okay.
So it was showing that failed to create pod sandbox.
So have you checked the status of the pod?
Yes, everything was okay, and I have run everything, but only one issue was there. After that, also I have run that image
No, what
forward.
is the status of the pod? When you say cubes, you get pods, what you're
Running.
getting? It's in running state, right?
Yeah.
Can you able to log into the pod?
Yes.
Okay, so what is that error you're getting?
I'm getting that error.
No, you said there is an event, right? Fail to start something.
Failed to create pod sandbox. After that, last plugin type flannel failed.
Uh,
Load flannel subnet environment failed.
okay, so just give kubectl get pods hyphen all hyphen namespaces. Check whether all the Funnel Network plugins related pods are running. So it's something like
Which command? Can you just
get pods hyphen all namespaces.
Yes, I have given all a running state.
All are running, correct?
Yeah, everything was running.
Then there won't be any problem. There might be some,
I think some
event.
installation issue.
It's not about installation actually.
Okay.
When it is trying to deploy or create deployment, it might not get the call. So on the second attempt, it might get the one. That's not an issue. If it is running successfully, then it should be fine.
Everything was in running status. Nothing
Then it
was.
should be fine. No need to worry.
Okay.
Because we are not relying on our a dedicated server, right? The virtual machine, what we're using, it is a shared resource. T2 micro instance that too.
Yes.
Correct. So sometimes we might not get that complete availability of that server. So there might be some deviations. Because of that, such fluctuations will be there, but it should be okay if all things are up and running.
Yes.
So when you set that issue, what are all things I ask you to verify? Can you remember?
Events.
I ask you to
to check all the event status.
Then
Then
I asked you to check the pod status, whether it's up and running or
yeah,
not. And I
yes.
asked you to check all the network plugin status, right? So these are all
Right.
the methods or steps to diagnose the issue. Correct. Tomorrow in future, if you get such things, this is the way you should quickly get into that and understand whether all the things are up and running as per the our definitions or not.
So
Once it is up and
pods
running, it's fine.
status and plugin status all are mentioned in that after describe command, the whole thing you told to check in that only, right?
Yeah.
That was running. Nothing is failed. Everything was okay. Only that one message I was getting that
Okay.
failed.
Got it.
Like,
Got it. So shall we continue now? Others?
Hello, Lok sir.
Yeah.
So namespace is nothing but within a cluster you're making groups, right? Like worker node 1 and worker node 5, worker node 10, they belong to this namespace, like that, right?
No, it is not about grouping your worker nodes. It is at the cluster level. I said it is a logical entity, not a physical entity. We are not going to map any physical machine or worker nodes to a namespace. It is a logical partitioning of a
Partition.
Kubernetes cluster. If you want it to be more clear, I'll give you one example. You have in your machine, you create folders, right?
Yeah.
Correct?
Yeah.
In your file system, you create folders,
Folder.
right? What is the size of a folder?
Size of a folder. I don't know.
In KBs, 1
Huh?
KB. In KBs, 1 KB.
Size
In
of the
KBs,
folder, it is purely depends upon the files that you save in that folder, right?
Yeah.
folder. Yeah.
The size of the folder, whatever you have,
Folder.
it is purely
Correct.
depends upon the objects that you have in the folder. Like if I
Folder.
say file1.txt, if the file text file is having 5 MB means the size of the folder will be 5 MB. Correct?
Correct.
So this file is what your physical entity which is occupying a physical memory. What about the folder? Is that a physical or logical entity?
It is logical.
Logical. Same way I can have another folder. This is folder 1 and this is folder 2. Here I can have some number of files, right? So now what is the size of this folder 2?
10
MB. Correct. 10 MB we can have now.
Yeah.
So what it means here, folders are the logical entity which
Folder.
can have some files, and the folders are available in one particular directory. It will be in D drive. Correct?
Correct.
In one directory, you create a folder. Within the folder, you can have your files. Similarly, your namespace. It is a logical entity. How you are partitioning your drive into multiple folders. If you say folder 1 and folder 2, you are actually partitioning your drive, right?
Correct.
You are not directly saving your file in D drive. Instead,
Yes.
you partition this D drive into 2 different folders now and maintaining your files there. Correct? Like this, you have a Kubernetes cluster. You are partitioning the Kubernetes cluster in the form of namespaces, which is just a logical entity.
Okay.
Within the namespace, you're going to deploy your pod. Then it will be assigning its own objects like pods or services, anything. So the folders can be compared with your namespace for your understanding purpose. Easy.
Okay.
Why we create a folder? Why can't I directly save the file here? Because depends upon my requirement. Consider this folder, I want to maintain all my application Java source code. Here I can have .NET source code. Like this, I can have another folder for my personal content or data, whatever, right? So depends upon a requirement, we're just creating some partition and maintaining our entities there. Similarly, depends upon the environments. We create a namespace.
Names.
Or it can be depends upon the specific team also. Understood?
Yeah, now
Yeah.
it's very clear.
Sorry?
Now it's very clear actually.
Right. So that's it. So let me get into my Jenkins here and let's run this pipeline project again. Where this file? Ayo, node is offline. I have to start the slave node also now. It's running, right? It's loading. Okay, tomorrow will be a half for you, right? I mean, you'll be coming on Thursday evening, correct?
Yes.
Can we have one task assignment for you in this module?
Yeah, sure.
Yes.
Okay. You have already done this, okay? I just want you to repeat this, okay? But it should be mapped with your Kubernetes also. So your first task is to practice all the Kubernetes concepts, whatever we covered. Okay. Even if you're not covering your namespace, all those stuff, at least try to complete this deployment object. I want every one of you to practice this with the example which I'm going to share with you. First, practice it. Understand how to deploy, create replicas, how to scale up, scale down, upgrade it without any downtime and all. Once you practice this, especially your deployment, okay. Once this is done, your next step is to execute your Jenkins pipeline. So in that pipeline, what you did there actually, you perform SCM checkout, right? Correct?
Yes.
And then
Yes.
you perform application build, correct? I don't want you to deploy in Tomcat. You just have two stages in your pipeline. Like I have something called disk space is below threshold. Blah, 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 blah. My node is out of space actually. Okay. So what should I do now? I need to clean up. That's all. Okay. So what is the command to remove an image? Docker image. We have a command to remove it. So Docker RMI. If you want to remove any image from your local machine, you can use the command Docker RMI followed by the image name. Let me remove this. No response, no such images. Okay. Oh, it is something related to your tag, right? Let me add it. 3. It's removed. Similarly, latest. It's removed. So if you want to delete any image from your system, you can use Docker RMI command, remove image. command to remove that image. While removing the image, just ensure that you use your, I think we have created this image, right? Java app build image, app build server. Is that Jenkins and all? I mean, Maven and all we have there, right? Okay. Similarly, let's remove PL app build. And here is a catch. I am trying to remove this image, and while removing the image, showing an error like unable to remove because this image is being referred in one of your containers. So now if I say docker ps-a, IO, I have these many containers are available. All these things are in exit state. But still, if I use an images list, this image, it is being used in one of your containers. So whenever the container is referring any image, you cannot remove that image. That is why you are getting this conflict. Can you see this? This image is being referred in this container C45. Got it? So you cannot remove it. So what you can do here is first you should remove that container, and then you can able to remove that image. This is all the way a process of cleaning up. Okay, if you want, I can add it in your notes itself directly. So docker rmi followed by the image name. This is to remove docker image from local machine. Similarly, we have another command called docker rm command followed by the container ID. This is to remove your docker container from the local machine. Okay, so what I'm going to do here is I have huge list of containers in my machine. It's totally not required, I think. Is it required? No, not required. So what I can do, I can simply say docker rm followed by the container ID. So just use the container ID one by one. In my slave node, I just have 1 GB of RAM and 1 CPU. And these containers and the images are occupying all those things. That's why my slave node is not coming up. So what I can do there, I can clean up. These activities is also, we'll be doing the same in a real-time environment also. Remember, I was talking about some build periodic option, remember? In Jenkins.
Yes.
Yeah, yeah, yes.
I'm
Job
giving one
scheduler.
real-time scenario, okay? When we say build periodic option, it is used to execute a job based upon some cron tab, right? So what I can do once in 2 days or every day evening, I can delete all the images or containers which are obsolete to save or create more spaces, right? So now I can see there is no containers, and now I can see there are some images, right? From I. See, now it is removed. After removing that container, I'm able to remove this image. Similarly, let me remove. We need Ubuntu or what? No, not required. Ubuntu is not required. And red is also not required. RMI. And then what else? CentOS is also not required. And Tomcat. Which version of Tomcat we are using? Have you verified the Docker file in my demo? I share the source code repository, remember? in the source code repository, we have a Docker file, and here I'm using 8.5. So I can keep this 8.5 and remove everything. 8.0 I'm removing now. So I have just only one image, Tomcat 8.5, and all other components are removed now. Easy. Reboot. Reboot is just to reboot your machine. What is the alternative to this? My slave node that is not getting attached to my Jenkins. It clearly says that disk space is below the threshold limit. Right. So what I did, I just removed all the things one by one. This directory is completely filled with those things. That's why I just cleaned up everything. Right. Alternately, what we can do? Any guess?
We can add volumes.
So yes, we can add more volumes. So we have a concept called volumes here. Go to this volume and you can create a volume. How much volume you want to create? What is the size of the volume? What is the property of the volume? What type of volume it is? Create, in which region or availability zone, create everything. Once it is created, it will be cataloged in your volumes list here. So the volume, whatever you created now, it will be available in the list. Select the volume, go to action menu and attach that volume to your, here there is an option to attach. Attach that volume to your instance, EC2 instance. Got it? Like this, we can able to add more volumes to your instance. All those things will be in your AWS module, okay, in the upcoming things. So this will be the day-to-day activity, okay, in a real-time environment. If you see server maintenance to ensure high availability of a server, everything matters here. But we never get into that such situation. Like here, you can see I'm unable to attach my Jenkins master node, right? Sorry, Jenkins master node with a slave node, right? But in real-time environment, we never give such a low configuration. Even if it is low configuration also, we never get into the down state. We'll be having some threshold limit. We'll be using some monitoring tools like Prometheus or AWS CloudWatch to monitor the health status of the node. If the health status is getting down, right, to a certain threshold limit, we immediately respond and fix that issue. See? So any question here? All right. So now let's get into the node. Let me
In
restart.
this course curriculum for Kubernetes, there was one component with the name what was that? Services.
Sorry.
In the Kubernetes module in our curriculum, there was one component with the name services. If you will open that PDF, so
Yeah.
so as per that component for services, I believe it is referring to those services like node port and
Yeah,
load
that's right.
balancer.
Yesterday we talked about it. There are three types of services: cluster IP, node port, and then load
Cluster IP.
balancer. Yeah, we
Okay.
talked about it.
Yes.
So also yesterday we have created one node port service, how to
Yes.
expose your pods to internet, right? So we
Mhm.
just created it with a simple pod. Same thing I'll show you how to create with the deployment object. Because in real-time environment, when you try to deploy a pod using your deployment control object, you have to create that node port service at the deployment control object level, not at the pods level. Correct? So
Yes.
I'll talk about it. But before that, I want you people to know, be comfortable with the steps what we created. So let me start this instance again. See, it is trying to launch now. It is trying to launch. Yeah, now you can see it is launched. Earlier it was saying offline. We noticed. Hope you noticed, right? Earlier it was saying offline
Offline, yes.
because of some memory issue. When I cleaned up the volume, now it is available for access. So these are some quick remedies, okay, you can able to do. If you are ready to pay and invest, you can add more volume and attach it. Otherwise, just go ahead and clean up your existing unwanted contents. Simple. So you got one new scenario today, right? So now let's get into the pipeline project.
It is taking time because the configuration of our VMs is pretty low. That is the reason.
Yeah. So we get into this page. Let me remove this policy also is not required. And let me remove this stage. Deploy to target is not required. So I just want to identify the source code and perform the Maven build. I want to create the artifacts for now. That's my requirement. Okay, so once the artifact is ready, I'll show you how to create a Docker image out of it. So let me apply the changes and run this job. So it has started build number 11. And it's completed now. So it means if I get into my, what is the server? My slave node, if I take the public IP address of this node,
Looks like your screen is stuck again.
so if I get into this node, I'm just logging into the slave node now.
Okay.
This is my build server. And this is my Kubernetes master. This is dummy. So now let's get into this node and DevOps admin. And here you can able to see there is a war file. Sorry, what is it? Workspace. And here I have that folder available. Within the folder, you can see there is a target folder. And we have this artifacts available there. And if I come out of this target folder, I have a Docker file. So what we are going to do with this Docker file means you're going to use the existing image called Tomcat 8.5 image. And with that image, I'm going to deploy my artifacts. So the artifact is present in target folder. In this workspace, I have a target folder. And from the target folder, I'm going to pick up this WAR file and copy it into my Tomcat application server. And then I'll be exposing to port 8089, for example. So before that, what is it called? So if I say Docker images, I have just Tomcat image. So let me exit and show you. Like, what is it called? Docker run -it followed by the image name 8.5 in bash mode. Let me create a container, and I just want to run in interactive mode. I just want to show you the deployment path. So this is a deployment path, and here I have web apps folder. In this web apps folder, there is nothing. We don't have any components or any directories in the web apps folder as of now. Correct? Let me exit from this container. All right. So now what we're going to do here is we are going to create one image out of this. So let's run a command, docker build command. Guys, I'm expecting every one of you to do this, okay, in next 2 days. Docker build. I think till this pipeline you're comfortable, no? How you got this artifacts in your workspace folder, you got the point, right?
Yeah,
Using a
yeah.
pipeline, we did this. Application build stage, just create the artifacts. Once the artifact is ready, from your workspace folder, you're going to run a docker build command. Because we already kept our Docker file in our source code repository, so we got it here. Docker build, what's the command? -t followed by that image name, the new image which you want to prepare. Loci /pl web app :v1.0 space dot. So this is the image which I am going to create with the version 1.0 and using the Docker file reference. Easy? Hope you're clear with this. Let me run this command. It is trying to prepare the image, and one new image has been created here. And once the image is created, if I say Docker images, I should be able to see one new image is available here. So what I'm going to do here with this image, I can able to create a new container, correct? Possible, no? Yes or no?
Yes, yes, yes.
Docker images, and I can able to use this image 1.0 in bash mode. I'm not going to run a Tomcat server. If I want to run Tomcat server, I never use this bash terminal. I just want to check whether the artifacts are properly copied to the directory. So I just want to execute in a bash mode, that is your interactive mode. And now if I say ls and get into the workspace folder, or sorry, web apps folder, see that WAR file is published here. Because as part of our image creation process, we are given a command. It has to pick up the default image, that is Tomcat 8.5 as a base image, and then we are running a copy instruction. What I said about copy? Copy instruction. COPY is used to copy the files from your host machine to your container volume. Correct?
Yeah.
That is what happened here. So it means my web application is deployed in my container. It's not running now. We are not running that actually. We just create one container, but it's not up and running. Service is not running actually. But it is clear that we have a artifacts available in the image. Let me exit from here. Now, if I want to run as a service, what I can do? Docker run -it followed by the image. Can I use a mount parameter? Sorry, publish parameter -p 8086 colon 8089. What does it mean here? What does it mean?
Port mapping.
Port mapping.
Port
Host port
mapping. Port mapping, right? So your host port and the container port. So what is the container port we have here in this Docker file? It is 8089. I just want to map it with my host port. Easy. Or if you want, you can give 89 also, no problem. Your host port also can be same. That doesn't matter. I don't know any problem because it is available. Sometimes in your host machine, your host port might not be available. So in the case, you can give different port numbers. Now, if I run this, see what is happening here. Now only your actual Tomcat service is running. It is running with that catalog sh script and it is starting the Tomcat service. And here, while it is up and running, so you can able to verify your Tomcat target directory. This is Tomcat temp, and there should be something called Tomcat web app folder. All right, so now its services started. It's up and running. So it is also deployed your application there. Okay, your application deployment also successful now. So it has deployed the application as well as it has started your service. It is up and running. Easy. Am I clear with this?
Yeah, and Loksa, you mentioned that that host port as 8089 because we allowed the all traffic there.
That's what. Easy. So now your application is successfully deployed in your container. Right. So things are clear now. How we are managing our
Yes.
entries. So it is just a process of deploying your container. So it means my image is ready now. So all that I'm expecting from you people is I'll be sharing this manifest file with you, the deployment manifest file. First, you practice with this. Okay, first you practice with this. Once you're comfortable doing this, then you just simply replace this Nginx image with your own image. That is something called, where is it? This one, like this. Is it possible?
Yeah, we'll try
You
for
want
sure.
to do with your deployment object, or if you want, you can do it with the pod object also. If you want to deploy one copy of pod with your application image instead of Nginx, just use the image which you have created here. So this is your task. So first point, practice all the core concepts whatever we discussed so far. And second point is you're going to execute your Jenkins pipeline to prepare the build, and then using a Docker build, create an application image using the Docker file present in the workspace. Okay, once this is done, you should publish the image to container, that is your Docker Hub. Once you publish this to Docker Hub, what you can do? Once you publish this to Docker Hub, you can able to
create the pods.
Deploy the application image in Kubernetes using a pod manifest file. Easy. So this is your task for next 2 days. Take some time first, understand the basics, and then try to complete this. Don't seek help. Okay, this is your task means try it by yourself. If you're unable to understand or if you can't do it, if you admit that you cannot do it, then come to me. All right.
Sure.
But that's the reason first I'm expecting you to practice all those things. In next 2 days, if you're unable to practice, means don't start with this process. I don't want this. All right.
Sure.
So try to plan your time and complete this. Hope things are clear, right?
Yes.
All right, then carry on. We'll connect the next session. Thank you.
Sure. Thank you. Are you launching the poll or should we leave?
Guys, I'm audible. Hello. Guys, I'm audible to all. Hello, Motion or guys, I'm audible.